All right, so for today, we're going to be working on questions 1 through 12. We're moving into unit 7 now. So first of all, we're going to talk about radicals. Now, some people call this square roots. That's when the base is 2, the root is 2. But if it's root 3, root 4, root 5, so we're going to call this by the proper name, radicals. So that looks like this. But we're familiar with square roots, so I'm gonna find the perfect squares, right? The perfect square is a number, like for example, the square root of 4, the square root of 9, the square root of 16. I'm finding the perfect squares, and then we call those perfect because I can think of a number that multiplied by itself will give me 4, or will give me 9, or will give me 16. As a matter of fact, we know the square root of 4 is 2. The square root of 9 is 3. The square root of 16 is 4. I can continue, right? I can think of a number. Like I could think of a square root that's going to give me 5. And the way I think of that, I'm like, oh, 5 times 5 is 25. So the square root of 25. I can find out a number. I can find out the square root that will give me a 6. The way I do that is like, oh, 6 times 6 is 36. So I'm going to find out that the square root of 36 is 6. I can find that square root of 49, 64, 81, 100, 121. Right, this list can continue on and on and on. So we are familiar with perfect squares, right? They simplify to a whole number. Now we're going to be dealing with radicals or roots or square roots that are not quite perfect, but we're still going to learn how to simplify. For example, the square root of 300. I'm looking at question number 1. I have to simplify this, and I'm gonna break this. I cannot think of a number that multiplied by itself is equal to 300. And if I type it in on my calculator, it's going to give me a decimal. But I'm not asking for the decimal. I'm not asking for you guys to evaluate. Evaluate is when when I'm expecting a numbered, probably as a decimal one. I'm not asking for that. I'm asking to simplify this. What I'm going to do, my square root, the square root of 300, let me break this into 2 square roots, so 2 radicals. And I'm going to think of 2 numbers that multiply together, it's equal to 300. However, one of the 2 numbers has to be a perfect square, right? The square root of something. Now, I can think of 30 times 10. If I think of 2 numbers that multiplied equals 300, I can think of 30 times 10. However, neither of them, neither the 30 nor the 10 are perfect squares. So that I cannot use those numbers. Like I said, one of your numbers has to be a perfect square. Okay, I can think of 4 times 75. 4 times 75 is 300. One of them is a perfect square. And then to be honest, the way I find out, I start dividing my numbers. I divided 300 divided by 4, and it worked. If it didn't work, I could have tried 300 divided by 9, 300 divided by 16, 300 divided by 25. I use division just to see if one of my perfect squares matches. Now we know the square root of 4 is 2. So this becomes a whole number. And this whole number, so this 2, multiply with the number on the outside, this becomes 20 square root of 75. Notice how I made my numbered inside the square root. I made it smaller. So I simplify a little. Now simplify as much as you can. Now I simplify to 20 radical 75. Simplify more if possible. So I'm going to look at this as if I was starting from the beginning, but instead of 10 radical 300, my question was 20 radical 75. So I'm looking at this as a brand new question. I ask myself, can I simplify square root of 75? Can I break this into 2 radicals? I grab my calculator. Can I think about it? We go 75 divided by 4. Gives me a decimal, so it doesn't work. 75 divided by 9. Doesn't work either. 75 divided by 16. Notice I'm dividing by my perfect squares, right? I divided by 4, divided by 9, divided by 16. No, it doesn't work. How about divided by 25? 75 divided by 25 is 3. So I'm going to break this as 25 times 3. Right? 25 times 3 is 75. So I don't have this anymore. Now, the square root of 25, remember, I have to get a perfect square. The square root of 25 is 5. Now, this 5 multiplied with this 20. So once I'm able to get a perfect square, which becomes a whole number, I multiply with the number that was outside to begin with. So 5 times 20, I know is 100. So I get 100 radical 3. Now my radical 3 cannot be simplified even more. I can't simplify that more. So then that's it, 100 radical 3. Now you might be asking, how am I going to type this? I don't have the square root symbol. And then don't go and copy the square root symbol and use parentheses. Instead, we're going to use the name. So the way I'm going to type 100 radical 3, we're going to type this as 100, right? The number 100. But radical, we're going to abbreviate this as RAD for radical. And then inside parentheses, I'm going to put a 3. Right, there was a 3 inside of the radical. So inside parentheses, I put my 3. I use RAD because I'm not going to ask you guys to type in the whole word radical. Okay, so just 100 rad 3, 100 radical 3. We're going to use RAD as the proper name, right? Because it's not just a square root. It could be a cube root, a fourth root, fifth root. So we're going to call this 100 radical 3. That's how we're going to type this all together. No spaces, no nothing, just all together. Now, interesting, let me erase this. Interesting that you can simplify faster. Remember how when you started learning how to simplify fractions, remember sometimes it took you a few steps and then sometimes you just solved it in one step? Let's say I had 10 radical 300 to begin with. Let me show you guys another way how to solve this even faster. 300, I have to break this into 2 perfect squares. Remember how initially I broke it as 4 times 75? What if I go 100 times 3? All I'm looking for are 2 numbers that multiplied equals to 300, but one of them has to be a perfect square. I know the square root of 100 is 10. And I'm going to say the bigger number that you have as a perfect square, the faster you're going to get to the answer. And then remember I said, once you get a perfect square, that whole number, you have to multiply to the number that was outside to begin with. 10 times 10 gives me 100. 100 radical 3. Now, how do you do it? Do you simplify in many steps or do you simplify in one step? It's up to you. The thing is just get to the correct answer. Simplify as much as you can. All right, so let's take a look at this. 9 radical 392. Okay, so let me just write it up here. So 9, the square root of 392. So 392, I'm going to break this into 2 radicals. And I'm thinking, all right, 392, can I divide it by 4? And I even use my calculator, and I get that 4 times 98 is equal to 392. Okay, so I did split it. I'm using 4 because 4 is a perfect square. I know the square root of 4 is 2. So now this 2, I'm even going to highlight this. This 2, once I have a whole number, multiply with the number that was outside to begin with. So now I have 18 radical 98. I simplify a little. Then I ask myself, probably I can simplify more. I'm looking at 18 radical 98 as if it was from the beginning, right? What if I started with this? So radical 98, I'm going to break this into two radicals. So I'm thinking, all right, two numbers that multiplied equals 98, but one of them has to be a perfect square. And I'm going to say 49 times 2. I know the square root of 49 is 7. So make sure you know the list of the perfect squares. If you want to write them down on a piece of paper, I'll recommend you guys do that. Okay, so I know the square root of 49 is 7. Now that's 7 with a number that was on the outside to begin with. So 7 times 18, I know is 126. Let me highlight that I'm multiplying this 7 with this 18. So that gives me 126 radical 2. Then I ask myself, can I simplify the radical? We're going to stop as soon as we cannot simplify the radical. And then radical 2, there's nothing we can do. So the way I'm going to type this will be 126 rad, and then inside parentheses, A2. It's 126 radical 2. We're going to call this by its proper name, radical. Okay. So that's how we simplify radicals. We can also multiply radicals. The way we're going to do this, we're going to multiply the numbers outside to begin with. So there's a -4. Technically, when there's a space outside, we call that a 1. When I'm multiplying the numbers on the outside, so to begin with, I'm going to have a -4 on the outside, and then I'm going to have radical 30. Notice how I multiply my radicals, 6 times 5. So you're going to multiply whole numbers with whole numbers, right? The numbers outside, multiply them. Technically, the space outside of the radical 6, technically it's a 1. So empty spaces are technically 1. So I multiply those two numbers. So that's how I got the -4 on the outside. And then multiply your radicals. 6 times 5 gives me 30. Then ask yourself, can you simplify your radical? Remember, I have to split it into two radicals. So for me to simplify radical 30, I have to split it into two numbers that multiplied equals 30. But one of them has to be a perfect square. In this case, I cannot, because I can think of 6 times 5, but neither the 6 nor the 5 are perfect squares. I can think 3 times 10, but again, neither the 3 nor the 10 are perfect squares. So no, I cannot simplify. Like I said, in order for me to simplify, I'm thinking two numbers that multiplied, in this case, 30, but one of them has to be a perfect square. Okay, so nothing I can do. So that's it, -4 radical 30. The way I'm gonna type this, I'm gonna go -4. For the radical, again, I go RAD, and inside parentheses, I'm gonna write 30. Don't forget to close the parentheses. That's a mistake that happens a lot. Don't forget it, because otherwise Canvas is gonna mark it wrong for you. Now looking at question number 4. Remember, first I'm going to look at the numbers outside of the radicals. This empty space technically represents a 1. So on the outside, I have 3, because I multiplied those two, right? 1 times 3. Inside the radical, let me multiply my radicals. 4 times 2 is 8. Okay, so I have 3 radical 8. Now simplify. This radical can be simplified because I'm going to split 8 into two numbers that multiplied equals 8. One of them is a perfect square. So I'm going to think 4 times 2, because the square root of 4 is 2, right? It becomes a whole number. Now this 2 with this number that was outside to begin with, I get 6, because I multiply those out. 6, but I still have a radical 2, right? I'm talking about this radical 2. So 6 radical 2. Radical 2 cannot be simplified anymore. So I'm just going to write 6 rad, and then inside parentheses 2. Now let me simplify a radical, because sometimes it's funny. There's a radical that gives people a little bit of trouble. So let me explain that. Square root of 36. Now, some people come and say, oh, I can split that. I can split that as 4 times 9. Because 4 times 9 is 36. At least one of my 4 or the 9 is a perfect square. So that's fine. I know the square root of 4 is 2. I know square root of 9 is 3. So some people are like, oh, what do I do when there's no more radicals? That means your number to begin with was a perfect square, right? When you multiply this 2 times 3 gives me 6. But then think about it. The square root of 36, wasn't that 6 to begin with? So when you're simplifying and you don't have any more radicals, because all your radicals cancel out, right? They become whole numbers. That means that you had a perfect square to begin with. Okay, now let's continue. Again, I'm going to be working up until number 12. So let's take a look at number 5. How we're going to simplify radicals. Now, when we have a fraction, it is okay to have a radical on the top, but it is not okay to have a radical at the bottom. So again, it's fine to have a radical on top of the fraction, but not at the bottom. The way I'm going to get rid of the radical from the bottom, in this case, let me multiply top and bottom by 1, right? We know that in multiplication, when you multiply by 1, nothing happens. But my fraction here, I'm going to write my 1 as a fraction. Now, how can I write a 1 as a fraction? Don't I have to have the same number on top and the bottom? I'm going to use radicals. I'm going to use radical 2 over radical 2. Notice I'm multiplying by 1. Again, when we multiply by 1, the value does not change. So I'm not changing the value, multiplying by 1, but my 1 is kind of fancy because it looks like a fraction, but I have on the top and the bottom the same thing. If you're wondering where the radical 2 came from, I'm using the radical that is at the bottom of the fraction. Okay, so let's see what I have now. I have radical 6 on top. Because I can combine those. Radical with the radical, I can combine those. Now at the bottom, when it comes to whole numbers, I just have a 5. When it comes to radicals, I have radical 4. I multiply my radicals. Now, when I multiply them, radical 4, that just became a perfect square. I know the square root of 4 is 2, so that became a perfect square. So now what I have is radical 6 over 10. Because I multiply the 5 and the 2 at the bottom. Okay, when we're simplifying radicals in a fraction, there's 2 rules that had to be met. Well, 3 rules. 1, no radicals at the bottom of the fraction. Okay, we're good so far. And then 2, simplify your radical if possible. And then simplify, the third one will be simplify your fractions of whole numbers if possible. Okay, so some of you guys are wondering, okay, no radicals at the bottom. The radical 6 cannot be simplified. So that's it, radical 6. Now, my last thing that I said is simplify your fraction of whole numbers if possible. Okay, what do I mean with that? I'll come back to number 5 in a minute. What do I mean with that? Let's say that I had like 8 radical 3 over 10. Okay, we could simplify that 8 with the 10, right? That's what I mean with simplify your whole numbers if possible. Here for number 5, we don't have that. Here, number 5, there's nothing I can do. That's it. Like radical 6 over 10 will be my answer. My radical that I have is simplified. I have no radicals at the bottom, and my whole numbers are simplified as well. Now, how are we going to type this? Okay, let me worry about the top of the fraction first. The top of the fraction is a radical 6. So the way I type that is rad, and then inside parentheses 6. I could type in the top of the fraction first. Everything that you have on top of the fraction. In this case, radical 6. And then for me to tell Canvas I'm going to write a fraction, I'm going to use the backslash. You guys see this on your keyboard towards the bottom on the right. And then after the backslash, I'm going to write a 10. So that's it. Radical 6 over 10. Okay, let me explain this really quick on the typing. This slash right here, it's basically I'm telling I'm telling Canvas that I'm typing in a fraction. Everything before that is what's on top of the fraction. Anything that is after that is at the bottom of the fraction. Okay, so radical 6 over 10. Let's take a look at number 6. One thing we can simplify, if I know that if I had a fraction of whole numbers, 15 over 10, we could simplify that a little, right? 15 over 10, divide each by 5, becomes 3 over 2. Same thing it happens with radicals. Radical 15th over radical 10th, I'm going to say this simplifies to radical 3 over radical 2. Again, if you had a whole number, 15 over 10, that simplifies to 3 over 2. In radicals, because you're basically dealing with numbers, you keep the same idea. Just they still remain radicals though. So now we have radical 3 over radical 2. And I know the way I'm going to get rid of the radical at the bottom, I'm going to multiply top and bottom by radical 2. Again, the radical 2 is the number that I have at the bottom. So that gives me radical 6 over radical 4. But the square root of 4 becomes a whole number. Radical 6, right? The square root of 6, nothing I can do. So this becomes radical 6 over 2. And the way I'm going to type that, I'm going to write radical 6 over 2. Now, some of you might be wondering, Mr. Leonzo, what if I did not see that 15 over 10 can be simplified? And I just went radical 15 over radical 10, and I multiplied top and bottom by radical 10. So I get radical 150 over radical 100. What if I did not notice that? Okay, you will have to simplify things, and then things will simplify to radical 6 over 2. You're like, oh, how do I do that? Okay, so the way I'm going to say it is radical 50, break it down into 2 radicals. So I'm showing you the long way. Break it down into 2 radicals, 25 times 6. And then we know the square root of 100 is just 10, right? So we have that square root of 25 is 5. So we have 5 radical 6 over 10, which simplifies to 1 over 2, right? The 5 over 10 is 1 over 2, and then radical 6. Now, when there's a 1 in front of a radical, I don't have to write it. So radical 6 over 2. What I'm trying to say is, try to simplify your numbers before you work out. Notice how I simplify 15 over 10 as 3 over 2. Notice how I work a little bit. If you don't simplify your numbers, you will get the correct answer eventually, but you're just going to have to work more. So try to simplify your numbers before you work. Okay, so let's continue. Again, we're going up into number 12. So we're going to be looking at one rule that we call Pythagorean theorem. That happens when we have a right triangle. When we have a right triangle, given 2 sides of a right triangle, we're going to be able to solve for the third side. It says find the missing side of each triangle, leave your answers in simplest radical form. So given a right triangle, so let me just write a right triangle here. We know the largest side of the triangle is the hypotenuse. In this case, let me call it C, okay? So the hypotenuse, the biggest side of the triangle, let me call it C. The other 2 sides, we call those usually the legs. You guys learned that in the first semester. We call those the legs of a triangle. But I'm gonna call one of side is A, the other side is B. It doesn't matter which one is A and which one is B. So I'm just gonna call this A and this B. And Pythagorean theorem states that A squared plus B squared is equal to C squared. Big emphasis, the letters that by itself is the hypotenuse, the longest side, which we call the hypotenuse. Okay, that's the C. The other 2, which one's A, which one is B, it doesn't matter. So for number 7, I'm going to say my 13 is my C, that's my hypotenuse. The hypotenuse is the one side that is the longest. And then we can identify if it's the longest because it's the side that is farthest away from the 90 degrees. We can compare the length. It is the longest side. And then my X and my 7 are going to be my A and my B. Which one is A? Which one is B? It doesn't matter. So let me call this A. Let me call this B. So I'm just going to say X squared plus 7 squared, it's equal to 13 squared. Remember, A squared plus B squared equals C squared. Okay, I know 7 squared is 49. I know 13 squared is 169. So let me write this as X squared plus 49 is equal to 169. I'm trying to get the X by itself. So the X squared in this case, my plus 49, let me move it over as a minus 49. So that's going to give me that X squared is equal to 120. I am solving for X, not X squared. We talked before, the exponents, the way we get rid of exponents is using square roots. So I'm just going to say that X is equal to the square root of 120. Technically what I did the square root on each side, because square root and squared exponent cancel each other out. So X is the square root of 120. When I look at my instructions, it says leave your answers in simplest radical form. Okay, so I got to simplify 120. So I'm thinking the square root of 120. I'm going to break this into 2 radicals. One of them is a perfect square. So I think 4 times 30. The square root of 4 is 2. Multiply this 2 with the number that was outside to begin with. I don't see anything. I'm assuming it's a 1. So now I have 2 square root of 30, or 2 radical 30. Simplify radical 30 if possible. In this case, I cannot. So that's it. My answer is 2 radical 30. The way I'm going to write this is 2 rad, and then inside parentheses 30. 2 radical 30. Nice. Let's take a look at number 8. My hypotenuse, my C is here. That's the longest side. And the other side, I'm going to call this 8, and I'm going to call this B. And I remember A squared plus B squared equals C squared. So I'm just going to go 6 squared plus 6 squared is equal to X squared. I know 6 squared is 36, so I have 36 plus 36, it's equal to X squared. I know 36 plus 36 is 72. So I'm going to say that the square root of 72, it's equal to X. But I have to simplify my radical form. Okay, so thinking 2 numbers that multiplied, it's equal to 72. I know I came out with 72 because I went 36 plus 36. When I repeated addition, isn't that multiplication? So can I just call this 36 times 2? Because I know the square root of 36 is 6. Multiply with the number that was outside to begin with. This 6 with the number that was outside to begin with. If I don't see anything, I'm assuming it's a 1. So I get 6 radical 2. Nice. The way I'm going to type this is 6 rad, and then inside parentheses 2. I want to emphasize that the unknown, the X value, sometimes is the hypotenuse, like it is in number 8. Sometimes it is not, like you guys see in number 7. Don't think that the last number is always X. Now, one thing, when the 2 sides are equal, 6 and 6, oh, there's a nice rule that we're going to learn later on, okay? So keep that in mind. 6 and 6 gave me 6 radical 2. Beautiful. We're going to learn more of that later. Take a look at the questions 9 and 10. Find the missing side of each right triangle. Side C is the hypotenuse. Sides A and B are the legs. Leave your answers in simplest radical form. Remember, we have that A squared plus B squared is equal to C squared. So I'm just going to write, I don't know what A is, right? So at the side, let me write A is equal to X, because I have no idea what A is now. So I'm just going to write X squared plus the square root of 17 squared. It's equal to 6 squared. So I have that X squared plus, the square root of 17 squared. Remember how I said earlier that a squared, an exponent with a radical cancel each other out? Square root with second exponent cancel each other out. So I just get x squared plus 17 equals 36. Nice. Those are actually nice to work with. Now I want the x squared by itself, so I have to get rid of the plus 17. Let me move it to the other side as a minus 17. So I get x squared is equal to 19. That means that x is the square root of 19. Can I simplify? Right, square root of 19, that's as simple as it can be. So my answer for this case will be radical 19. Cannot simplify more. All right, so for number 10, I know that A is 11, C is 14. So I'm going to say that B is equal to X. I don't know what B is. Okay, so I'm just going to write this as 11 squared plus X squared is equal to 14 squared. So I'm going to write that 121 plus X squared is equal to 196. Right, 11 squared, right, 11 times 11, that's where I got the 121. And then 196, I got it from 14 times 14. Okay, so I want the x squared by itself, so let me move the 121 as a minus 121. So I get x squared equals 196 minus 121 is going to give me 75. So x is equal to the square root of 75. Okay, simplify if possible, because it says leave your answers in simplest radical form. So I'm thinking square root of 75. I'm going to break this as 25 times 3. Remember, one of them has to be a perfect square. The square root of 25 is 5. So my answer is 5 radical 3. And the way I type this is 5 rad 3. 5 radical 3. One thing I want to emphasize. When you squared a radical, you just get the number in the inside. So let me go over some rules on those. If I was to ask you the square root of 5 squared, you just get 5. The square root of 7 squared, you just get 7. When you square the radical, you just get the inside. Now, what if I have 3 radical 2 all squared? What if I have to square that? What I expect you guys to do is square the 3, square the radical, and then combine. Okay, so what do I mean with that? 3 squared is 9. Radical 2 squared is 2. Because remember, the squared and the square root cancel each other out. And then I said combine. 9 times 2 will give me 18. So keep that in mind. When you just have a radical squared, you just get the number in the inside. However, if you have a whole number and a radical, square the whole number, right? Square the radical and then combine. Beautiful. Let's take a look at our last 2 questions for today. State if each triangle is a right triangle. Okay, so What I'm asking is this corner 90 degrees? Now, it kind of looks like it, but how do I know it's not 89 degrees or 91 or even 89.3 degrees? How do I know it's exactly 90 degrees? Interesting is that we know the Pythagorean theorem. We know Pythagorean theorem is a squared plus b squared is equal to c squared. Happens only if I have a right triangle. So I'm going to check if the Pythagorean theorem works. I'm going to check if a squared plus b squared equals c squared. Now, I'm assuming this is my 90-degree corner, right? So I know this is going to be my C. The hypotenuse is the side that is farthest away from the 90-degree corner. So in this case, C is the one side that is farthest away from the corner I'm assuming is my 90 degrees. And then I'm going to call this side A. Well, I have to call one of my sides A, and the other side I have to call it B. So I'm going to call this side A, and I'm going to call this side B. Which one is A, which one's B? It doesn't matter. What matters is the C, the hypotenuse. And then I'm just going to square each of these, right? So I have 5 radical 7th all squared. Let me write it like this for right now. 5 radical 7 all squared plus 9 squared. It's equal to 16 squared. I'm checking if this is true or not. Remember that I said when you squared a number that has a whole number and a radical, remember I just said that a few seconds ago, I expect you to go 5 squared, radical 7 squared. Remember I said square each and then combine. I know 5 squared is 25. Radical 7 squared is just 7. And then combined, I know 25 times 7 is 175. So all this became 175. So 5 radical 7 all squared is 175. Remember, I did 5 squared, I did the radical squared, and then I combine. Okay, plus 9 squared, I know it's 81. And then 16 squared, right? 16 times 16, I know is 256. What I'm asking here is 175 plus 81 equal to 256, right? Use a calculator if necessary, but yeah, this is true. So now here, state if each triangle is a right triangle. Yes. If my last statement, and I'm talking about this is my last statement, if my last statement makes sense, right? If it's a true statement, then yes, this is a right triangle. So I'm just going to say yes. Yes, it is a right triangle. If my last statement doesn't make sense, and what do I mean with doesn't make sense? 2 plus 3 equals 9. Right? That doesn't make sense. So if my last statement doesn't make sense, then no, this is not a right triangle. All right, let's take a look at question number 12, our last question for today. Question number 12, I'm going to say my hypotenuse is this side. That's my hypotenuse. So I'm just going to go radical 45 squared plus 4 squared, because I call this A and I call this B. Radical 45 squared plus 4 squared, it's equal to radical 66 all squared. Okay. Radical 45 all squared, that's just 45. Because remember, when you square a radical, you just get the number on the inside. So 45 plus 16, right? Because 4 squared is 16. Radical 66 all squared is 66. So now I'm asking, is 45 plus 16 equal to 66? I know 45 plus 16 is 61, not 66. So in that case, no, this is not a right triangle. My last statement has to make sense. If it doesn't make sense, no, that's not a right triangle. So your answer will be either yes or no. Let me zoom out to what we did today so you guys can take a look.